So as we saw in the last example, we had a repeated root that was repeated 3 times. So anytime I can factor something and put it in the form of x minus the root to the nth power, we call those multiple roots. So if it's even, it's going to touch the axis but doesn't cross it like a parabola. So it'll bounce off the axis, something like that. If it's odd, it's going to look cubic. So it will go through the axis, but it'll flatten out a bit where we have the root. So let's look at these sketches. So my roots are going to be -2, +1, +3. And then I always want to think about my y-intercept. My y-intercept is going to be 2 times -1 times -3, so that's +6. Also, this is going to be a cubic graph with a positive a value, so the shape is going to look like this. So I'll have something that will come up. We don't know if this is the maximum, so don't draw it as the maximum. In fact, because this root is so close, I think my maximum is probably going to be somewhere here, and then I'll come through and come somewhere down here. So if you don't have your calculator, we can't know for sure where it is. But if we do have our calculator, obviously we would calculate the max min. Something else I could have done is I could have plugged in -1. So if I plugged in -1, I would have had 1 times -2 times -4. And I was so close, I should have come all the way up to 8. I could also plug in 2. So then I would have had 4 times 1 times -1, which would have been -4. So I should have come down some more this way. So let's go back and add those points in. So I'm going to add in 2, -4. So I'll come up to -8, down, and then back up again. All right, here I have x plus 1 squared. So that means at -1 I'm going to bounce, and then at 2 I'll go through 2. My y-intercept is going to be 1 times -2. This has an a value that's positive and it's cubic, so it will look like this. So I'm going to come up, bounce off the axes, come down. I should plug in x equals 1. At 1, I'm going to have 2 squared times -1, which will be -4. So I'm going to come down to -4, and then I'm going to go back up again. So in this case, I do know that this is my local maximum because I'm bouncing off the axis. All right, let's try this one. So in this case, I don't have a factored polynomial, but I see a common factor, so I'm going to take that out. I'm going to get x minus 1 cubed times x minus 1 from here, and then minus 4 from here. So that's going to turn into x minus 1 cubed times x minus 5. So I'll have 1, 2, 3, 4, 5 if I count every 2 boxes as 1. And I could have -1, and that's going to be a cubed root. I'm going to have a y-intercept at +5. So 2, 4, 5 if I count this way as 5. And now I want to think about what's going to happen with my shape. So I've got a quartic, x to the power 4. My a value is positive, so my shape is going to look like this, except I know that I'm going to come through here. Ooh, that doesn't make sense. Was I supposed to hit? Oh, x minus 1 means I go through +1. Whew. All right, so let's come through +1 with a cubic shape. So let's go. And then I'll come up. Again, I don't know exactly where this minimum is without putting it into my calculator. Okay, last one. This is -1. I see 4. This looks like a repeated root. It's repeated 3 times. At 2, this is repeated twice. And at 4, I'm just going through it once. So I'm going to say that this equation is a x plus 1 cubed, x minus 2 squared, x minus 4. I can see by looking at the graph that my a value must be negative. So I have an x to the 6th power. That makes sense because it is definitely an even power graph. And I go through 0, 4. So 4 equals a times 1 cubed, negative 2 squared, times negative 4. All right, so I'm going to get 4 equals negative 16, no, 4 times 64. Oh, sorry, 4 times 4 is 16, negative 16a, so then a is negative 1/4. So now I have my full equation coming back and replacing my a with 1/4, negative 1/4. X plus 1 cubed, x minus 2 squared, x minus 4.